Good day, good day, good day, and welcome to Africa Teen Gigs. While we're presenting the STEM Digital School. If you have just joined in, this is the grade 10 Physical Sciences class. Today is the 3rd of July 2020, and yes, we are ready to do some more physical sciences. If, like you guys have known, since we started on the 1st of July, we have started with term 3 work. So if you have just joined us for the first time today, just know that we are doing um, term 3 work. But I'll show you how it has been readjusted from the Department of Education. So I hope that everybody is doing great and everybody has been doing their homework, and we're just going to have a great time, and I hope that everybody is learning. And please, guys, if you have any queries, any questions while I'm teaching, you guys can just send me a chat quickly. We don't usually do the voiceovers. Yes, I'm the only voice that's speaking. So in most times, you can just send me a chat when you have anything that you want clarity on. Okay. So this is a picture of me here. I am your teacher. My name is Nonkulilego Matondo, and I'll be catering your physical sciences classes for the rest of the term. Another thing I want to remind you guys is that I am working from the Oxford Successful Textbook. Uh, no, I'm not working for the Oxford. I'm working from the Siavula textbook and the Study Master. But any other grade 10 textbook will surely do the trick. So whatever textbook that you have, just follow through according to the chapters, and yes, you'll be able to get all the knowledge that you need to do. Looking at quantitative aspects of chemical changes, we had just finished yesterday the physical and chemical changes with regards to chemical changes. Um, and I hope that it's starting to slowly make more sense for you guys. And just going ahead, reminding you the summary and the amendments that have been made with regards to the syllabus for this year 2020. For grade 10, they've removed magnetism. So if you do have magnetism under like that you have been studying already, just stop and cancel it out. It's not going to be part of your end of the year exam for 2020. And in chemical changes, which is what we are doing right now, they've only removed the reactions in aqueous solutions. So everything else is still there. We'll still have the um, physical and chemical changes. We have the quantitative um, aspects, which is what we're doing now. And we're also going to do the representation of chemical change. Okay. So, yes, this is what I wanted to tell you. We usually have this chapter in term two, but for this year, we are having it in term three because everything has been changed due to the COVID-19 lockdown. But now these are the ones that we are working with. So we're here in the middle actually, because as you can see here, they said for term two we must do physical and chemical changes, representing chemical changes, and quantitative aspects. These are all grouped into one term. So now we are here on the quantitative aspects. Okay. Reminding you once again that we are working from the Oxford Successful textbook, and you can get it on Snaplified. If you have Snaplified, you can go there and you can download it, and you can start getting all your free textbooks there. It's absolutely free up until the 31st of December. You can get free textbooks there, not just for physical sciences, for all your other subjects as well. So if you are interested, just get the Snaplified app. You can even get it on your mobile phones, and you can get all your textbooks that you feel like you need. Okay. So another thing that has been removed in the syllabus is the chemical systems. So which means we won't be doing chemical systems at all. As you can see, it counts 0. So we were not going to be doing that. Okay. So getting back to our contents, okay. Today we're doing the quantitative aspect. We're going to be doing the introduction. We're going to do the mole. We're going to do relative molecular mass and relative formula mass. We're going to do molar mass and relating molar mass and the number of moles. I think it's also relating molar mass with the concentration, with the volume and concentration. So those are the things that we're going to be focusing on today. I hope that you guys have got it right. Okay. So in our introduction, I just want to explain basically the whole picture when it comes to the chemical changes. Okay. So in this module, we will discuss the quantitative relationship between reactants and products in chemical reaction. This relationship is known as stoichiometry. Okay. So stoichiometry is what we're going to be doing now. Basically, that's a quantitative aspect of the quantitative aspects of chemical change. Okay, so chemists use stoichiometry relationships to find out how much product will be made from specific amount of reactants. Okay, this enables them to perform experiments in laboratories and in large scales and in big industries. What this basically means is that sometimes for them, let's say they are required to make an X amount of chemical that is maybe 20, 20, 20 grams. Okay. So what they want to know is how much out of that whole 20 gram they're going to require a specific substance. So that's why we do stoichiometry, because they need to calculate how much of that substance they're going to need for them to reap their result or the product that they are looking for. So that's why it's so important, because that's when they get to know, okay, I'm going to need 5 grams of chlorine in order for me to make 20 liters of HCl, for example. So I hope that makes sense to you guys. So basically, that's what it means when it talks about quantity, the amount, how much is needed, how much is going to be a yield, for example. Okay. So we'll discuss how to calculate a yield from a chemical reaction, the formula compounds from analytical data, the volume of gases made in reaction, and concentration of reacting solution. So this is a structure of basically when we do stoichiometry, we have the molar volume and gases. We've got the molar and molar concentration, and we also have the reacting solutions. So this is the part where we're going to be balancing our equations and stuff, but we're going to do that more when we do the representation of chemical change. And yeah, basically this is a structure. So let's get onto it. The mole. What is the mole? Okay, now we're going to go to the mole concept. The mole is the SI unit, the SI unit for measuring the amount of a substance. Okay, the amount of pure substance containing the same number of chemical units as there are atoms in exactly 1 gram of carbon 12. Okay, so what the mole is that, for example, it's a unit that is used to calculate anything. So for example, when you have when they give you a certain number of mass, you're going to first convert it into the moles, calculate it against another substance, and then from there you're going to convert it back to the mass that you're looking for the other product. So moles is basically the standard measure that is used to calculate for chemical equations. Okay, so it's always moles. Whatever you get, first you convert it into moles, and then you find what you're looking for. Okay, so the amount of pure substance containing the same number of chemical units as there are atoms in exactly 1 gram of the carbon 12. So another thing that we have is the Avogadro's number, which tells us how many particles there are in 1 mole. Okay, so in 1 mole, we have 6.022 times 10 to the power of 23, Na, which is the Avogadro's number. Okay, so the symbol N is used for the number of moles. Okay, so the number of moles. This is what we. This is the standard. I mean, you're gonna have one moles, for example. Um, it's a mole, but it's in moles. I hope that makes sense. But I've got a small I've got a I've got a small example for you guys here. It says 5 mole of water. Determine the number of water molecules and hydrogen atoms. So what we know about water is that it's H2O, right? So when you balance the chemical equation, because you're obviously going to have H2, because remember, whenever they say you work with gases, it doesn't just come standing alone. It's going to be a hydrogen gas and a oxygen gas. So it's going to be H2 plus O2, and that will give you H2O. But to balance out the equation, this hydrogen atom, you're going to have to add a 2 in front, and also add a 2 on the water molecule. So meaning that if you're going to try and calculate the number of moles, the H2O molecule is going to have 5 mole times 6.2022 times 10 to the power of 23 particles of water molecules. Okay, so remember we said 1 mole of substance is equals to this. So 5 mole of that substance will be equals to 3.01 times 10 to the power of 24. I hope you guys are understanding this, okay? So for the hydrogen atom, there are 2 hydrogen atoms per molecule of water. Why? Because when we balance the equation, we had to add a 2 to make sure that they become balanced, because the O was not accounted for on the O2 molecule, okay? So the H atoms, it's 5 mole of water times 6.02 times 2. This is a 2 that we used to balance the equation, okay? So we don't have it here on the H2O because the H2O is already a water molecule. So this is going to be this 5 mole of water times this times 2. And this will give us 6.02 times 24 H atoms in 5 mole of water. Okay? But it's fine. Don't get too stressed. We're still going to get to it, okay? But just to do a small exercise for the particle substance, the Avogadro number. Let's see what there is that we can do with it. So, says 1 dozen egg is used to describe 12 eggs, right? Calculate the number of eggs in 2 dozen. Can somebody think what could the answer be there? So 1,000 is equals to 12 eggs. So 2,000 means that it's 12 times 2. So basically, why are we doing I just got disconnected for some time, but I'm glad that I'm back and I'm glad that you guys are patiently waiting for me. So I'm just want to check with you guys. Is this the last slide you guys saw before you got disconnected? If this is it, please can you just show me with a show of hands um, if this is a slide where you last got connected. Okay, so I hope that you guys understand now the concept of the egg theorem that I was trying to use to explain to you guys basically what it means when it says 1 mole of 1 mole gives you 6.022 um, of the Avogadro constant. Okay, it's like basically it's something like using the egg theorem of saying 1 dozen gives you 12 eggs. So with moles, it's 1 mole gives you 6.002 times 10 to the power of 23 particles. Okay, so I'm just going to move on from that because I can see we might end up losing some time. So going forward to the relative molecular mass, um, what is the relative molar? Okay, the relative mass, the mass is the the relative molar mass is the mass of 1 molecule of a covalent substance, okay? Covalent substance, sorry about that, in atomic mass unit. It is calculated as the sum of the relative atomic masses of the atoms in a molecule, okay? So a relative formula mass is the mass of one formula unit of an ionic substance. Okay, in atomic mass unit, it is calculated as the sum of the relative atomic mass of the atoms making up the formula unit. Guys, these for example, the relative formula. This is a this numbers are there. When you check in your periodic table, because in this chapter, we're going to be using a lot of the periodic table. There is a number which is the relative formula. It's really a number that has comma, something, 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 something. That is the relative formula. So those are things that you must check, especially, and you need to know, especially when you're doing the molar mass calculations, because as you see, as we're going along, you're going to notice there's something that you'll only be able to get through the periodic table and you will not be told. So it's something that you will have to know by yourself. Okay. So the molar mass. The molar mass is an element of an element is the mass of 1 mole of that element. Okay. It is equal to the atomic mass of that element expressed in gram per mole. Okay. So the molar mass of any substance can be calculated from the chemical formula for that substance. So here's an example of a molar mass, okay? This is a molar mass. Let's say they give you this and they want to know what is the molar mass of this substance. Basically, you're going to go to your periodic table. In the top right corner, you'll see a number that usually has comma something, 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 okay? So you're going to take it and write for copper, it's 63.55. And when you're doing the molar mass, you add them together. The only time you multiply is, for example, with oxygen here, it's O4. You're going to times it by 4. And for this whole thing here, the H2O, you're going to put it inside a bracket and times it by 5. So these are the only times you multiply, but ones that are sitting next to each other like this, you have to add them together. So it's going to be copper 63.55 plus sulfur, which is 32.07, plus um, plus oxygen, which is oh 04, it's 4 times 16. So you see here, they might have written a dot, but it's not a times. It's also, you add them again, plus 5 times this whole bracket, it's going to be 2 times 1.01 for hydrogen, plus 16. Do you guys get it? I hope that it makes sense to you guys. Basically, this is how you calculate the molar mass, and it's very important because you will need it in all your calculation when you're calculating, when you're doing mole calculations, and it'll always be in grams per mole or gram times mole minus 1. Okay, so this is how you get it done. So this is the molar mass. That's one most important thing that you need to know when you're going to be calculating the molar mass. Okay, but we will go through some more examples on the textbook. I just want to first explain to you guys all the concepts, and then you can go back and revisit them. Okay, so for an example, remember we spoke here about formula mass. Is the relative formula mass of one unit of an ionic substance in an atomic mass unit. It is calculated as a sum of the relative atomic masses of atoms making up the formula unit. So an example of that, let's say they give you a sum like this, and they say calculate the formula mass of copper 2 nitrate. What are we going to do? You're going to go and get your copper nitrate formula, which is CuNO3 times 2, and you're going to go and find your atomic mass, which is also the molar mass, basically, of each of them. And then you're going to do the formula mass. So basically, the formula mass and the molar mass is one in the same thing. The formula mass, if they ask for formula mass, you're just going to, instead of, you're going to use the atomic the U for the unit there. And for molar mass, you use grams per mole. Okay. So do you guys see the difference? There's no difference actually. The only thing is that it's the unit at the end. For molar mass, it's grams per mole, and for the formula mass, it's going to be the U. Okay. So moving on. How to calculate the number of moles? How do we calculate the number of moles? So the number of moles is going to be given by mass divided by molar mass. Okay, so N is the number of moles of the substance. M is the molar mass that you have to find by yourself, and the mass is what is given. So what you'll get usually in a question, they will ask you calculate the mass, calculate the mass of, for example, they can say calculate the mass if you've got 5 mole of carbon, or they can say calculate the number of moles if you have 3 gram of sodium. Okay, and once they give you such a calculation, you know already the first thing that you have to do, you need to go and find the molar mass. How do you find the molar mass? On your periodic table, you add them together, you times where it's applicable. Okay, how can I help you, sister? Is there somewhere where anybody's getting stuck? If you are getting stuck anyway, you can just let me know where you're getting stuck. Okay, so just send me a chat. Hello. Okay, you can just send me a chat wherever you're getting stuck, and I'll go back and explain it to you guys, because the main point here is for you guys to understand. So the number of moles. Okay, so this is how we calculate the number of moles. Okay, are we together?
Yes.
Okay, so now we're moving on to relating the number of moles First, we related the number of moles with the mass. When they talk about relating the number of moles with the mass, this is the formula because you've got the number of moles and you've got mass. So mass is directly proportional to the number of moles and inversely proportional to the molar mass. Okay, so that is the relationship between the two. But this is not the only relationship we have. We only also have the relationship between um, the number of moles and concentration, because sometimes you can be given mass or you can be given a volume to calculate. Okay, so from the definition we write the formula: C is equals to N divided by V, where C is the concentration of the solution in mole per dm minus 3, and the N is the number of moles, and the V is the volume of the solution. So they can ask you any one of these. Okay, they can ask you to find the concentration, they can ask you to find the volume, or they can ask you to find the number of moles. But usually they usually ask for the volume. Okay, and if they do so, it means that automatically, because you've been given mass, you'll have to calculate the number of moles first. And how are you going to get that? There should be a mass that is given in your question. So you'll use this formula first.
Keep going now.